Okay, for 69, it's a horizontal line, and it says identify the common function. The common function is a parent function. The parent function is for those 6 functions that we had to deal with, and y equals c was one of those parent functions. It was a horizontal line. Okay? Now, it says describe the transformation. Well, what happened to this thing? Up, down, left, right. What? It went down 2, because you can see the tick marks. David, it's very confusing. I had to look at it too. The tick marks are, you said what?
I said down 2.
Oh, I apologize. The tick marks were the axis, so therefore you needed to look, and it went down 2 units. So how do I write that? What's the equation? Great with that. Do you understand that? Okay. 70, what's going on with it? What's the parent function? F of x equals the absolute value of x. What's happening to that thing? It went up 3 units. So how do I write that?
Absolute value of x plus 3.
Good. 71. F of x equals x cubed is the parent function. And what's happening to this? It did go down 2, and it reflected over the y-axis, which means what are we doing here? Negative x cubed minus 2. Do we understand that? Yes or no? Do we understand that?
Okay. I screwed it up. I did like percentage plus 9, and then I did.
Oh, no, we're getting 9.
Well, it's in the 6, so the scale is going by ones, and the scale is from -6 to 6 on the x-axis and on the y-axis. Are you talking about 70 or 71? On 70, it's going by units of 1 on the x and the y-axis. What's the -6 and 6 for?
To tell you that the window is from -6 to 6. That's it. So the x window starts at -6, ends at 6. The y window starts at -1 and ends at 7.
Okay.
You with me?
Yeah.
Okay. All right, 72. What's going on with 72? It is going to be the square root of x. And what's happening? It's reflected over the x, which means what? A negative is in front of it, and then what's happening? It's going to the right 3, so where do I put that? Underneath the radical, -3, because it's going to the right. Do we all understand that, yes or no? Okay, so now, moving on. Going to the next set of instructions. Now, h is related to one of the 6 common functions on page 42. Those are the parent functions I talked about. Identify the common function f. B, describe the sequence of transformations from f to h. C, sketch the graph of the transformation from f to h. And then D, use the transformation notation to write h in terms of the common function f. I'm not worried about letter B. Okay? However, if I really wanted to be picky, you should have been able... I'm not worried about it. Never mind. We're not even going to worry about it because you guys have tests tomorrow. I'm not going to stress you out. Okay? So, what I want to do, 73 through 83, we're all in the back of the book. You should be able to check your work. Okay? So, 72, 74, 74. What's the parent function? F of x equals x squared. Now, what happened to it? It went to the right 3 and down 2. Good. How do I expect you to write that? Right 3, down 2. How do we graph that? Well, here is x squared, which is the parent function. Then I'm literally picking up the vertex. I'm picking up the vertex. Now I'm going to go to the right 3 units, 1, 2, 3, and then down 2. Do we see that? Do you see how easy that is to graph that? Okay. 76. This is the last one I'm going to do on the board. The rest are going to be all verbal. 76. Somebody else. Taylor, what's my parent function for 76? Sarah? It's x cubed. So f of x is equal to x cubed. And what's the transformation? It is going to be left 2, and then it's going to be up 5. Very good. So again, here's my x squared function, and I'm going to go to the left 2 units and up 5 to put me right here. Do we all see that? Yes or no? Do you have to draw the parent function first? You don't have to, but it's a really good way for you to say I'm taking it up and I'm moving. What do we get that? I'm sorry? Oh, that's x cubed. I put it in x squared. Sorry, guys. Thanks. My bad. There it is. Sorry, thank you. So I need to again go to the left and then up 5. Does that make sense? Thank you, Morgan. We good? Yes? Okay, now the rest are going to be verbal. So, 78. Jeff, 78. What's my parent function?
Absolute value of x.
Absolute value of x. And what's happening?
It's going to the left 8 and 1.
Left 8, down 1. Good. 80. Hold. Parent function x squared. What's happening to this bad one? Good. Wrong. It is reflected over the x. You have your up and your down, your left and your right confused. When it's inside the parentheses, that is when it's going left and right. So it's minus 2. So what's happening there? The opposite of what you think, so what's it going to happen to it?
For 80.
Or 80.
Go right 2.
It's going to go right 2, and then it's going to go down 8. Do you understand that?
Yeah.
Okay, 82. Who wants it? Morgan? 82. I want to do 81. I'm not doing 81. I'm not doing that. I'm doing even. 82. Morgan. X squared parent function. What happened to it? Compressed by 1/2. Up 6 and right 3. Excellent job. 84. Who wants 84? What were you done back there? 84. What do you got? Good. Stretch 3, down 5. Excellent job. Do we all understand what you needed to do for 73 through 84? Now I'm going to tell you straight up. If you guys can do that section, you have the entire back page of the test completely done. Cake walk central. Do we all understand this? How many of you felt like you had to grab the calculator to graph these things? You are not going to have time tomorrow to graph these. You need to be able to know what's going on. If you're uncertain, what do I want you to do tomorrow? I want you to put an asterisk beside it and go back to it. And then if you have time, graph it.
Because you can just do it it's actually typos.
It is. Matt.
32 compresses or shrinks? Or compresses or stretches?
Compresses because it's a fraction. Okay. All right, the next part was 85 through 94. This is going to be your adding, subtracting, multiplying, dividing two functions together, finding the domain, and then the composition of them. Now, with that said, this is going to be the easy part, because 86 says to do f plus g at 5. F plus g at 5. Well, f plus h, sorry, I looked at the wrong thing. F plus h at 5. Now, what is the f function? 3 minus 2x. What is the h function? Now, that is what f plus h is. Now, what is it asking me to do? To plug in a 5 for those. Every place I see an x, I'm plugging in 5. So that's 3 minus 2 times 5, dropping the parentheses because I'm not distributing. 3 times 5 squared plus 2. And that's 3 minus 10 plus 3 times 25 plus 2. So that's going to give me negative 7 plus 75 plus 2. Correct? And this is going to give me what? This gives me negative 5 to give you 70. Do we understand that, yay or nay? Could you combine like terms first and then plug them aside? Absolutely. You could have done either or. Do we understand how to do 86? That's your final answer? That's your final answer? On the quiz you will. I'll show you that in a minute.
What's 92?
We're not there yet. 88, what's G minus H? G minus H at 1, but what's G? Minus H, what's H? Do I need those parentheses there? Why? Because I'm distributing a negative there. Can I combine any like terms? No, so what do I need to do? I need to put it in 1. So that's going to be the square root of 1 minus 3 times 1 squared minus 2. Square root of 1 is 1 minus 3 minus 2. That's going to give you 1 minus 5 to give you negative 4. Do we all see that, yay or nay? We good? Okay, now 90. G. At 1, what do I do? What was G? What's H? Plus 2. Now what do I do? That's going to give you 1 over 3 plus 2 to give you a 1/5. Was this as hard as what you thought it was? It was very simple, wasn't it? Okay. All right, now 92. 92 is where the composition comes into play. Now, composition, this is the G of F at negative 2. How many of you do not like this notation up there? But what's another way I can write it? I can do G parenthesis F at negative 2. Now, what does it say I need to do first? It says I need to do F at negative 2. Well, what is my F function defined to be? What's that? 3 minus 2x. So I'm going to plug in a negative 2. So that's 3 minus 2 times negative 2 to give me 7. Now, what does F at negative 2 equal? What is F at negative 2? It's 7. So I can substitute that in that I need to do G at 7 now, correct? So now I'm going to do G at 7. And what is G defined to be? What is it? To give you the square root of 7. And that is going to be your final answer. Now, you didn't have to do that problem like that. How many of you did the problem exactly like that? How many of you did the composition first and then plugged in negative 2? What I would have done is I would have done F at G, or G of F first. Okay? What is G of F? Well, that means we're going to do G of F of X. What is F of X? What's F of X? 3 minus 2x. And what's G defined to be? The square root. So that's going to be the square root of 3 minus 2x, right? This is G of F of X. That's what that is. And then all you have to do is plug in what? A negative 2 in there to give you the square root of 7. I don't care how you do it as long as you do it. Okay, that's fine. Do we understand that? They're both correct. Okay, now I want to talk about domain. Can I finish what you need to know for the test first?
Yeah.
Okay. Okay. Now, let's say I give you these two functions, F and G, and I want you to add them together. What's that going to be? Square root of x plus 1 plus 2x minus 4. Can I do anything with that? Really that easy. Do we understand that? So if you have a square root and it's ugly like that, chances are you can't simplify it. Okay? But what if I have functions that look like this? And I want f of x, f divided by g of x. What's that? What's g? Am I done? Why? I need to split that bottom into two binomials. And then what happens? Then I'm left with 1 over x minus 1. I will mark it wrong if you don't reduce. Am I clear on that? Factoring into two binomials. Okay. Now, the next thing I want to talk about is domain. What's the domain of this? Top one up here. Think. When do we have restrictions before we even start? When do I have restrictions? An even root, and then even root would have to be exception would be what? What stuff, Zach? Good. The jump underneath the root has to be greater than or equal to 0. Excellent job. When else do I have? If you have a variable in the denominator. So what's my lovely little domain? So what's my domain? Don't tell me none. An element of the reals. I'm going to get really picky on this. What's my domain on this one? X is an element of the reals. X cannot equal 7. Do we see that? What about the next one? Nope. X is an element of the reals. X is greater than or equal to negative 3. Why? Because x plus 3 has to be greater than or equal to 0. So it has to be greater than or equal to negative 3. See that? Because this jump to square root has to be positive, which makes it be larger than 0. It can be 0, but it has to be greater than or equal to 0.
Is it just when it's a square root that it's
Even root. So now, look at this last one. And it's ugly. It's ugly.
so
We have 3 restrictions you need to be thinking about here. What's my first restriction? The square root. X plus 2 has to be greater than or equal to 0, so x has to be greater than or equal to negative 2. True? The next restriction is going to be my odd root. Do I have any restrictions on an odd root? No. Odd root, there's none. My next restriction is going to be what? The denominator. What can the denominator not be? 0. So what you're telling me is this whole thing, which is x minus 2, cannot be 0. Correct? So x cannot be positive 2. So now you have to put all 3 of these restrictions together and write it as one answer. So what is that? X is an element of the reals.
greater than or equal to
X cannot be 2. You know why? Because here's negative 2. Right? Right? But can it be 2 whenever you get up here? There has got to be a hole there. Do we see that? Do we all understand domain a little bit better? Alex?
What do you do if there's like a radical and the denominator, you just whatever's under the radical, you set it not equal to 0?
Yes. Unless this was an even root. If it was an even root, it'd be greater than it, and it cannot be 0.
So
Okay.
if it's even root, you find what it could be with the even root, and you find what it could be on the radical.
Yes. Okay. All right. Now, I want to quickly show you what's on the test tomorrow. I'm going to stop recording because I'm not going to show everybody the test. That would be on the line. Cheaters, pumpkin eaters.
Are we trying to get stuff that was did Thursday?